This problem is type 2. We resolve this into partial fractions. So what we observe here is both are linear factors only, but one linear factor is repeating. So if any of the linear factors is repeating, then we have to do like this: x minus 1 by x plus 1 into x minus 2 whole square can be written as a by x plus 1 for this linear factor, one constant by x plus 1, for this linear factor b by x minus 2. This repeated twice, so we require one more linear factor, c by x minus 2 whole square. X minus 1 by x plus 1 into x minus 2 whole square. The LCM is also x plus 1 into x minus 2 whole square. And here x plus 1 is satisfied. We have to multiply this to this a. So a into x minus 2 whole square. Already we have one x minus 2, so one more x minus 2 is required, and x plus 1. So x plus 1 into x minus 2, of course b is there, plus c times here x minus 2 whole square satisfied. We require x plus 1. Both sides we can cancel. Now, whenever you see only linear factors, instead of comparing x square coefficients or x coefficients as such, by simply substituting factors, making 0. For x plus 1 is a factor, x minus 2 is a factor. X plus 1 is equal to 0, x becomes minus 1. So substitute x is equal to minus 1 throughout. And the other time substitute x is equal to 2. See, I put x is equal to minus 1 because x plus 1 is a factor. Substitute x is equal to minus 1. Then see what happens. Minus 1 is minus 2. Minus 1 minus 2 is minus 3 whole square is 9a. If I put x is equal to minus 1, this becomes 0. Similarly, this becomes 0. So a is equal to, we got minus 2 by 9. Now this time put x is equal to 2 because x minus 2 is a factor. If I put x is equal to 2, 2 minus 1 is 1. This becomes 0. This also becomes 0. And this side 2 plus 1 is 3. C. So C value is 1 by 3. All factors are over. So with these factors, we got two constants a and c. I got this value, I got this value. Only one value is left. So if we got all values except 1, in that case, you put x is equal to any number in this equation. Any number means generally we take a very simple number. I take x is equal to 0. You take any number other than these two. So I'll take x is equal to 0. 0 minus 1 is minus 1. If I take 0 here, this is minus 2 whole square. So 4a. 0, 0, 1 into minus 2 is minus 2 into b. And there c. Now I substitute values 4 times. A means minus 2 by 9 minus 2b plus c is 1 by 3. So I keep this 2b here, or else 2, I'll send 2b this side and send 1 that side. This is minus 8 by 9. Already 1 by 3 is there. If I send this minus 1 that side, that would become plus 1. So 2b is equal to, LCM is 9 minus 8 plus 3, 3 is 9 plus 9 here. So 2b is 12 minus 8 is 4 by 9. So if I divide by 2 on both sides, it is 2 by 9 again. Thus we got b. Now substitute a, b and c here to get the answer. And now see type 3 problem. X square minus 3 by x plus 2 into x square plus 2. So the main difference is when you compare with the type 1 and type 2, we have a non-linear factor here. You know that for every linear factor, while resolving into partial fractions, for every linear factor, we require a constant in numerator, a by x plus 2. This is a second degree expression, and while splitting, we require a first degree expression in its numerator. 1 degree less than and a nonlinear factor should be written in its numerator. So this is the procedure to resolve this into partial fractions. After LCM, after doing LCM, we will get this. Of course, we can cancel both denominators after LCM. We will be left with this. Now, by substituting suitable values to x, we can obtain ABC values, or by comparison between these two, we can obtain ABC values. Here, I compared x square coefficients. So here x square coefficient is a, and here there is a possibility of b, because bx into x is bx square and its coefficient is b. Here x square coefficient is 1. Now comparing coefficients of x on both sides, this side no x and this side bx into 2 means 2b is x coefficient, c into x is cx, that is c is x coefficient again, plus c is equal to this side no x coefficient, so it is 0. And if you compare constants on both sides, 2a is a constant and c into 2 is 2c is a constant, so 2a plus 2c. This side constant part is minus 3. Now from this equation I can take c is equal to minus 2b, because c plus 2b is equal to 0. By subtracting 2b on both sides, I can get c is equal to minus 2b. Now 2c means multiplying 2 on both sides, therefore 2c would become minus 4b. In this equation, in the place of 2c I wrote minus 4b. So I repeated this equation again, 2a plus 2c means minus 4b is equal to minus 3. So this is an equation containing ab. We have one more equation containing a and b. So a plus b is equal to 1. By multiplying both sides by 2, we get this equation. By solving, we get b value, a value and c value. Now this problem comes under type 4. This is a linear factor. Type 4, a repeated linear factor should come, root whole square. So for a non-linear factor, so this is a non-linear factor. For a non-linear factor, I have to write a degree less than this expression. General expression whose degree is less than 1 means a first degree general expression ax plus b by x square plus x plus 1 plus, again this is repeated, for that I need to write again cx plus d by x square plus x plus 1 whole square. So after LCM and cancelling denominators, we will have a into ax plus b into this part x square plus x plus 1 plus the x plus b. Now comparing coefficients, of x cube first of all, because the maximum degree over here is x square into x is x cube. Only one, that is a, is possible here. Nowhere x cube is there. So directly a is equal to 0. This side x cube coefficient is not there, so a can be 0. Now comparing coefficients of x square on both sides, we have a chance of b here, bx square, and ax into x is also ax square, and here no x square, and here this side coefficient of x square is 1. So since a is equal to 0, b becomes 1. Now comparing constants on both sides, sorry, we have one more thing, comparing coefficients of x on both sides. So ax into 1 is ax, so its coefficient is a. B into x is also bx, its coefficient is b. Cx is there, so its coefficient is c, x coefficient is c, and this side x coefficient is not there, 0. So since a is 0 and b is 1, plus c is equal to 0, that implies c is equal to minus 1. This time comparing constants. So b plus d is equal to, here constant is 1, already b is 1, 1 plus d is equal to 1 means d is equal to 0. Now substituting these values here, a is 0 plus b is 1, so this 0 plus 1 is 1 by x square plus x plus 1 plus c is minus 1 into x plus d is 0 by x square plus x plus 1 whole square. Now this is our answer.